name is Don Parkinson, and I'm a senior consultation specialist with Atkins Realis. Today, we are continuing our series of live stream topics as our project moves closer to consultation round 4 of the environmental assessment phase. The topics we are covering parallel our project activities or are of community importance. So we hope these will help our viewers and listeners better understand the project and provide input along the way. I do not have my co-host today, Jennifer. She's not able to join me today, so I'm flying solo. So bear with me on that, and let's get started. Today's topic is the assessment of the project's effects on surface water resources. Through these WSR radio shows and live streams, we want to help our listeners better understand the results of the environmental assessment. So let's get started. First, I thought we would run through a list of the topics that we're going to cover today. We're going to do a bit of a background on the project just to get everybody up to the same level of knowledge about the project. As we know, there are some new viewers who may not be as familiar with the project as others. Then we're going to talk about the surface water studies that have been undertaken. We'll look at the results of the field surveys, and then we're going to talk about how you can continue your conversation with our team. So let's move now to talk a little bit about the project location. So Webequie First Nation is located about 200 kilometers from both Hudson Bay and James Bay. And the Webequie Supply Road is a planned all season road that would run from the airport in Webequie southeast to east of the Mukatai River in the McFalls Lake area, which is really in the heart of the what's called the Ring of Fire Mineral Development Zone. In terms of the purpose of the Webequie Supply Road project, one of the purposes is to move materials and supplies and people from the Webequie Airport to the McFalls Lake area. The second is to provide employment and economic development opportunities to Webequie while preserving their language and culture. And then finally, providing experience and training opportunities for youth to help encourage the pursuit of additional skills through post-secondary education. In terms of the project itself, let me give you a little bit of a breakdown on the project. So, um, the planned length is 107 kilometers, again extending from the airport in Webequie southeast to the McFalls Lake area. The length of the road, um, actually sits on Webequie First Nation lands, is 17 kilometers. So 17 kilometers are on reserve lands. The preliminary corridor width for consideration of route alternatives is 2 kilometers, which means that anywhere in that 2 kilometer wide band for the preferred corridor, the road would be situated. And we give ourselves that width to work with in the event that we learn of other constraints or things that might conflict with where the road is going to go. So that's what we call the planning corridor, the 2 kilometer wide corridor. And then the final corridor width is going to be 35 meters. That would be the right of way for the 2 lane road. In terms of other information, there would be 3 major water body crossings, as well as 23 other water body crossings. The 3 main water body crossings are of the Winiscus's Channel, as well as Winisk Lake and the Mukatai River at the eastern end of the project. Um, there would be, as I've said many times, it's more than just a 2 lane road. There are other facilities or infrastructure elements associated with it. So this would include temporary and permanent aggregate pit and rock quarry areas with equipment for processing, meaning breaking up the stone into appropriate sizes for construction. And then there would be access roads to get to those areas, as well as bridge structures or culverts in the event that these access roads have to go over water courses. There would be construction camps. There's planned to be 4 of them along the way. These would all be temporary, and they would be to accommodate construction crews and operations and maintenance offices, including supportive facilities such as wastewater treatment plants to manage the wastewater and potable water storage locations to provide drinking water as well. And then, of course, there would be storage and laydown yards. These would be temporary for equipment, for the storage of equipment and materials. So let's talk a little bit now about the actual surface water studies that have been undertaken on this project. So before we do that, let's talk about the purpose of these studies. So remember, we're talking about surface water here. Groundwater is another issue. But in terms of surface water, what we're trying to do is identify the potential effects on surface water resources as a result of the project, and then provide recommendations for minimizing um, uh, the negative environmental, health, social and economic effects related to surface water effects during all phases of the project, meaning construction, operations, and maintenance as well. In terms of what was studied, we break it down into 2 main categories: water quantity and water quality. In terms of water quantity, um, what we're looking at here is looking at potential changes to stream flows and water levels, as well as erosion and sedimentation processes at the water body crossings, and then looking at any changes to the overall drainage patterns in the project area. So we would look at the number and type of water body crossings affected by the project, how big these changes would be by installing these crossings, how they would affect the stream flow, the water levels, and we do this by doing actual physical measurements of the water courses and doing modeling, which is where we use computer software um, and look at effects given different situations, given different scenarios. We look at runoff rate, so how quickly the water runs off over the land, and then we look at uh, the catchment area for a given water body disturbed by a physical activity as well too. Um, we try to understand and describe changes to drainage patterns and the land cover, so the what's on the surface of the land, um, to because that provides sort of an indirect way of identifying the potential for erosion or soil loss and sedimentation, which is soil loss that ends up in the water courses and then settles out, um, uh, and can cause problems with water quality because it reduces the how clear the water is, the transparency of the water as well. So, in terms of surface water quality, which is the other aspect of what we're looking at, um, we're assessing potential changes to biological or chemical properties of surface water in the project area by looking at potential increases in the concentration of suspended solids um, or other chemicals in what we call the receiving water bodies due to potential discharges. So, in the event of a spill, what would be, we need to know the levels of different chemicals in the water now to have a basis for comparison, right? So sometimes in certain areas you have higher levels of metals, for example, in a particular area because there's certain types of rocks whose whose components, the metals in those rocks, release themselves into the water bodies. So the levels in the sediment, meaning in the bottom of the watercourses, or even in the water, can be slightly elevated. So we need to establish that baseline, and that's why we go out and do our field work, and then identify the quality of the water, meaning the chemical composition of the water. So let's have a look now at the results of the field surveys. And so we did a lot of work in the field associated with these water crossing locations. These were our primary areas of focus. So on this particular slide, you see all the water crossing locations, and associated with it on this map, you see these gray areas with a dark gray border around them. And what those are is what you call catchment areas. So those are the areas that drain to that point. So those yellow points that you see on the picture, um, all the areas in gray that are associated with that yellow point drain to that location. So they're able to figure this out by taking, we've done a survey which is called a LIDAR survey, where we pick up in very high resolution the height of the land. So we get millions of points that indicate the height of the land in different locations. And then we put all that together, and we predict in between those points to get what you call a surface, so a land area of predicted elevation or height of land. So that way we can see the area, we can figure out the areas that drain to a particular location. So that's what you're seeing on this map right now. And then at each of these crossing locations, we do what you call um, drainage area characteristics. So we look at each one in detail, and I'm going to zoom in on my screen to look at one of them. So I'm looking at the one on the left, which is WC2. We have a picture of where that crossing is, and then we have that little map with a pinkish color showing the drainage area to that point. And then we've got a lot of different information associated with that particular drainage, with that particular location in terms of the area that's drained to that point. Things like the slope, meaning how fast in that area the slope changes, meaning the elevation, the height of the land changes. The area of lakes and wetlands within that area. Um, the maximum channel elevation, so the maximum height of a channel or of a water course in that area as well too. So a lot of really detailed information, um, very detailed actually, and we can get into all kinds of stuff. But um, what it's used for is to identify potential impacts. So we look at different situations when we do our modeling, surface water modeling, also known as hydrologic modeling. And then we use that information to figure out what size of structure, whether it's a bridge or a culvert, to put at these different locations. So that's kind of the purpose of why we go into detail looking at these locations. So typically you'll have a water surface engineer or a water resources engineer who would do this work, and then they come up with recommendations for the structure. Like the size of the openings of the structure that goes into the watercourse or over the watercourse in the case of a bridge. And then at each one of these crossings, if we look at the next slide, we do a lot of we collect a lot of detailed information. Um, we identify the type of water body, the type of survey we're doing, flow rates in uh, meters cubed per second. And then we have things like other physical measurements of each water course. So we have things like wetted width and bank full width, and these are just different ways of describing the water course. So the stream or bank full is based more on um, the the width of the water course where the water would spill over onto the floodplain. Um, That's the simple description of it. And the wetted width is where the water is now, the width of the water course where the water is now. So we take these. Our field teams go out and they do these measurements. They identify where the high water mark was based on what their observations. They identify the substrate type if they can. Substrate means the bottom of the water course. Like, what is it? Is it muck? Is it silt? Is it gravel? Because that's important information, especially for fish habitat as well too. Um, we make observations as to whether there's beaver dams there. Um, we do things like wetted perimeter, wetted area, width, and then there's information the slope as well too. So we get all this sort of physical information about these water courses because we need to understand them and we need to understand how that water course will behave in different situations. And that's where the modeling comes in. Now, when we move to something like water quality, that's a completely different kind of activity where we're actually trying to get an understanding, as I mentioned before, as to what the chemical composition of the water is at different locations, at the different water crossing locations. So our team will take water samples at the different locations, and what you can see on your screen now is a sample of some of the information that's collected. So on the left side, the column on the left, that reflects the things that we were sampling. So we have things like pH, which is a measure of the acidity of the water, temperature, dissolved oxygen, turbidity, which is a simple way to describe it would be how clear the water is, and then general chemistry, which could be lots of different chemicals, testing for the levels of different chemicals. And then as you move to the right, you have a description of things like RDL, which is detection limits of the device that's used to do the measurements of the chemicals in the water. Units, it just describes what units are used. And then you have things like you'll see on here PWQO, CCME. Now, not to be intimidated by that, those are guidelines that are used to compare to. So the results that we collect in the field or that we get from the lab after the lab analysis is done are compared to these provincial water quality objectives and these other objectives as well, just to give us an idea of what the quality of the water is. Now, each area is different. Some areas have, as I mentioned before, higher levels of different chemicals just because of the geology of the area. For example, if there's metals that are released from weathered rock into the water, that might be reflected in the levels of the different metals in the water or in the sediment at the bottom of the water course. So then the other columns you see there, the WB-1 and WC-2, those are the names of the different locations, the dates that they were sampled as well too. So that's how we sort of summarize the results of our data. So basically, in terms of the results of this work, looking at the water quality side of things, because the water quantity side is more of a descriptive kind of thing, but the water quality thing side of things, there were not many exceedances of these guidelines, whether it's the Canadian Environmental Quality Guidelines or the provincial water quality objectives or the water quality guidelines for the protection of aquatic life. These were not common, which is not surprising because we're talking about a very undeveloped area. There's very little physical, like human activity that has gone on over the years of any scale. What we did find is there were some exceedances for field pH, meaning level of acidity of in the water or of the water, aluminum and iron. We found these in 2019, 2020, and 2021, all three sampling events. Again, these occurred in areas where there's very little development. So these are probably naturally occurring higher levels of these parameters of aluminum and iron in particular, probably from the weathering of rocks and maybe from potential sources, atmospheric sources from distant emissions, maybe from a distant upstream source, but highly unlikely, likely associated with the weathered rocks, I would say. So, really, when it comes to water quality, we have a good established baseline now that we can work with that will serve as the basis once the environmental assessment is approved, if it's approved. These the monitoring that will go on, the monitoring of water quality that will go on after the project has been built or during its construction will be compared back to these baseline results. And if we see things that are out of whack with those results that we got previously, then those will be investigated to see if there's any particular specific reason why we're getting these elevated values. So that work that has been done for the environmental assessment is very important because it gives us that baseline, that basis for comparison moving forward, because we all want to make sure that the um, environment is not impacted significantly by our project. So we need to make sure we have something to compare to. So I know that's a lot of information, but hopefully that it's clear to everyone, and they'll be able to. And if you, by all means, if you have questions, we encourage you to contact us through our website, supplyroad.ca, or you can email me directly if you have any questions. We're happy to share information. There's a lot of information on our website. And we're happy to talk to you about that information. Happy to talk to you further about the results that we've obtained, and we hope we can keep that conversation going forward. We would love to visit your community as well too, to talk to you about the results, or have a virtual community meeting, whatever works best for you. We would be happy to participate in that. So that wraps up today's discussion of the Webequie Supply Road Environmental Assessment Surface Water Findings. We hope it was helpful and encourages you to join us again. Starting next week, we'll be taking a break from the WSR live streams and radio shows to bring to communities consultation round 4 for the environmental and impact assessment, where we will be talking about cumulative effects. Don't forget to keep in touch with our project team members via the contact information available on our website, supplyroad.ca. Miigwech, and see you soon.